Let's get our hands dirty with Storm, and it's because I don't want to get into all the details of building and packaging and deploying Java code. We're just going to look at one of the samples that come with Storm included with it and try to understand how it works and actually run it and see how we can interact with Storm on your Hortonworks sandbox cluster here. So as always, I've kicked off the virtual machine here running the Hortonworks sandbox, and let's start by going into Ambari. So with our browser, we'll go to 127.0.0.1.80.80 is support as usual, and we'll log in as the admin account that we set up much earlier in the course. And a couple of things we need to do. First of all, so fortunately Storm is pre-installed on Hortonworks, so all we have to do is select that service and start it. So service action start and wait for that to kick off after we confirm it. Should start pretty quickly. Okay. And the built-in samples that come with Storm also include some Kafka connectivity. So we also need to make sure Kafka is started as well in order to avoid some errors when we actually start the built-in samples. So we'll just select Kafka as well and start that too. We're not actually going to be using Kafka for our sample here, but it will make the framework happy if it's running. All right. And with that out of the way, let's minimize our browser and open up a SSH connection to our sandbox, Maria_dev. All right, so let's go to where Storm lives. And as with most of these technologies, you'll find it under cd/user, usr, HTTP, current. And from here, we want to go into storm-client. Okay, so this is where all the root directory of the Storm client lives on your sandbox instance here. Let's dive even deeper and find some sample code that we can mess with. So that lives under contrib. And furthermore, under storm-starter, which is the name of the tutorial package that comes with Apache Storm, /source/jvm. We are looking at Java source here, which is organized under org Apache Storm. And finally, let's see, there's starter is the end of that path. So just to recap, this is the path that I've cd'd into. So under the Storm client directory, there's a contrib storm starter that has source for JVM with starter.storm.apache.org. Okay, so if we do an ls in here, we should see the sample code that comes with Storm. So let's take a look at word count topology as a simple example that we can run. So let's just take a peek at what's in there. Let's do vi word count topology.java. All right, let's take a look at what's in here. So as you can see, this is Java code, and it starts off with declaring the package that you live within and all the dependencies that you need to import into this this class that we're defining here. And you can see there's a bunch of stuff, and this is exactly why I don't want to get into the details of how to compile and package this thing, because that does get a little bit complicated. You have to install Maven and all sorts of fun stuff like that. But let's take a peek at what's going on. You usually do see Java in the context of Storm, that even though Storm bills itself as being compatible with any language you can dream up, in practice, pretty much every example and every tutorial you find out there is going to be based on Java. That's not a bad thing. I mean, a JVM-based language is always a good choice in production because that's going to give you the best performance, unless you're going to be writing in C or something like that. But this is actually an example that has some Python integration. It's the only example I know of that does. So let's take a look at what's going on here. So we start off by declaring a word count topology class. And just to get a high-level view of what we're doing here, what we're developing here is a Storm program that will just listen to a spout of incoming random sentences, and it will keep track of how many times each individual word appears over time as new sentences get received by Storm. So there are a few components we need to build here. One is a bolt called split sentence, and you can see here that all that's doing is calling out to a Python script called splitsentence.py, which presumably just calls split in Python to take an incoming sentence and split it up into words. And you can see here that we're defining the output of this bolt for split sentence to output a new field called word. So all that's going on here is that this bolt will receive a sentence and output a bunch of words that exist within that sentence. And then next in our topology, we will slap that onto a new bolt called word count, and that's where this is defined here, public static class word count. And what this does is it takes that tuple of words, and for each word, it will go through and update this map. That maps words to counts. So you can see we have a hash map of strings to integers that is maintained by this word count class, which is a bolt within Storm. So as each word comes in, as long as there's an actual word received, it will increment the count for that word. After retrieving what it was, update that hash map to reflect the new count and emit to your collector for Storm, your final results, a new value that contains the word and its updated count. Okay, so this very simple class here is just maintaining a map of words to their counts and emitting the new values as they are updated and received. And we declare here that our output fields are word and count. So it's pretty easy to follow along what's going on here. And finally, we have our main function here, our main function that puts it all together. So we have a topology builder that lets us build a topology and assemble all these components that we've defined above. We're going to set our spout to a new random sentence spout, which is just another class defined within the Storm starter kit that comes with the samples that come with Storm. And all that does is randomly pick one of a few sentences to output over time continuously. So it has a little library of different sentences that it will output, and it just keeps spewing them out in random over and over and over again. Next, we, in our builder, set a bolt, and that will be called split. That will use our split sentence class to instantiate a new split sentence bolt. And that will take our spout and take every sentence and split it up into words. So the next thing in our topology builder here is the count bolt, the word count bolt. So we slap that on to the split one, and we take input from words, and that will output our final results of word and count values that are emitted. Finally, we just set debug on our configuration because we want to see what's going on. Set our number of workers and kick it off. And that's all there is to it. So you can see, pretty simple as far as Java stuff goes. There's not a whole lot of code going on here, but you know, when you appreciate what's going on here, it's very much like Spark Streaming, where you can control a massive cluster and process massive amounts of data and just focus on the logic of what you're trying to analyze as opposed to the mechanisms of actually doing all this. So now that we understand what's going on here at a high level, let's hit :Q to quit out of this and kick it off, shall we? So to do that, we can just type in storm jar /storm-client/storm-current/storm-starter/storm-starter-topologies-star.jar. So the first parameter to Storm is just a list of all the code that you want to actually include in the package. So this is all of the jar files that contain the compiled versions of all the code that we're going to depend on to actually run this Storm job. The next parameter is just the class name that we want to kick off, which is org.apache.storm.starter.wordCount.topology. And finally, a name for this job, which we'll call word count. All right, so let's start that and see what it does. Does take a couple of minutes for this to start, but submitting it should be a little bit quicker. And this should just exit out as soon as it's been submitted to Storm itself. So all we're doing here really is submitting a job into Storm. As long as the Storm service is running on our Hadoop cluster, it will just run indefinitely until we explicitly kill it later on. All right, so there we go. We seem to have uploaded things into Storm, and Storm is now chewing on it and trying to figure out how to run it and kick it off and start it. So let's go to our browser and take a look at the Storm UI. So on Hortonworks, that by default, at least with HTTP 2.5, runs on port 8744. So let's take a peek. Cool. All right, so you can see here our word count job is showing up under our topology summary, but right now it has no workers and no executors, so it's still spinning up and still getting started. And actually on your sandbox here, it will take a couple of minutes for that to actually start doing anything. So I'm going to pause this video and come back in a couple of minutes when we actually see some numbers here when I refresh this, this user interface. So be right back. Okay, so about 2 minutes later, we can see that word count now has 2 workers going and 29 executors, so 29 different processes handling this job. So it's busy counting up words from random sentences as we speak. Pretty cool. So we can dive into that. Just click on the word count topology there, and we can see what's going on in more depth. So you can start to see some of the structure of what's going on. You can see our spout that we set up. That's the random sentence generator. And then the two bolts that we defined in our code, the split bolt that just calls out to a Python script to do a split, just to show that you can do that. And the count bolt that counts up all the given occurrences of a word over time. So that's just maintaining a big old hash map of words to counts. Cool thing, you can actually visualize the topology. So this one is actually quite simple, where we just have a spout that connects to the split bolt that connects to the count bolt. And that's the end of the story, but obviously you can do much more complicated things if you want to with Storm, and have entire graphs of flows that are working together and in an optimal manner, hopefully. So a good way to see what's going on under the hood there. And you can actually click on individual bolts to see what's going on as well. So if you want some more insight into what's going on inside the split bolt, you can get a few more stats here, like individual executors that are running. So we can see that it's running on a couple of ports right now, 6700 and 6701, as time goes on. So there you have it. And if we go back to the Storm UI, one important thing to point out in here is if you want to kill that, see right here it says it's active status. So this is going to run forever, or at least as long as the Storm service is running on your server here. You will at some point want to kill that. So when we're done, we're going to hit the kill button to actually make that job go away, because we don't want that running forever. That would be a little bit silly. But let's see that it's actually doing something. So let's go back to our terminal, and let's go to the log directory and see what's going on. So where are we? Let's cd into /user/http/current/storm client. And from here, we will go into the logs folder. And in here, you can see there's a workers artifacts. So because we didn't actually wire up that final bolt to actually store data someplace useful like HDFS or Hive or some database or something, it's just dumping this out into the log. So the only way to see the results as they're being generated is by looking at the logs themselves. So if we look here, we can see I've actually run this a few times before. We're on word count 4 at this point. So for you, just go into whatever word count folder you see. And within here, we see subfolders for each distinct port that we're running this on. So let's go into 6700 for one example. And we can see the output of the count bolt on the 6700 port. ls, and let's do an ls-ltr, and you can see that worker.log is the one we're interested in. Let's do a tail-f on worker.log. And all right, so you can see some of the output actually being generated here. For example, in this line here, we're saying that we emitted a updated count for the word "an," which so far in this stream has been found 2,435 times. And the word "the" has been found 9,988 times. And for some reason, -f doesn't work on tail on this box, but if we do it again, we should see some different numbers. Yeah, you can see "the" is now even more, and "an" is even higher as well. So let's do that one more time. Cool. The number 7 popped up, which apparently has been processed 5,739 times. So you can see it's actually working. Pretty cool stuff. And obviously there are more practical examples you could imagine of Storm, where you're actually connecting it to a stream of data coming in from Kafka or something and writing results out to, HDFS or HBase or something like that. But for now, this shows you at least what it's capable of and the fact that Storm actually does run. So there you have it. We got our hands dirty with Storm with the sample word count example that just counts up the number of words seen in a random stream of sentences over time. And now that we're done, let's Control-C out of this and we can exit out of the terminal. And remember to kill that topology now that we're done with it. So back in the Storm UI, let's kill it. And let's give it 3 seconds to die instead of 30. And now the 3 seconds have expired. I should be able to go back to the Storm UI, and sure enough, there's nothing in my topology summary. So at this point, things are back to normal, and it's safe to close everything else down. And there you have it. We can safely shut down our machine, our virtual image for the Hortonworks sandbox, and be done with it. So cool. That's Storm for you.